All right, seventh graders, today's a really important day in our unit talking about negative numbers because we're taking everything that we've been exploring so far with how to draw number lines and how to drag chips around in a chip model. We are culminating that into coming up with a way that we can predict whether the sum of two integers, meaning when we add together two integers, is going to be positive, negative, or zero. Let's really quickly remind ourselves where we've been. So we've been practicing writing addition sentences by using chip models and number lines. And here's an example of sometime that we might want to use a chip model. Right here it says Linda has 8 video games and her friend has 5, which means altogether they have 8 plus 5 equals 13 games. That's second grade level work. You know 8 plus 5 equals 13. But the seventh grade level part of this is that seventh graders can prove why that's right and show why it's right by using a chip model. So right here, I see 8 black positive chips for Linda's 8 video games. I also see 5 black positive chips for the games that her friend has, which means all together there are 13. You know how to do that. Easy stuff. You can also draw number lines. Here's an example of when we might have used a number line. A desert weather station, the temperature at sunrise was 10 degrees Celsius. It rose 25 degrees Celsius by midday. And the temperature at noon was then 10 degrees Celsius plus 25 degrees Celsius equals 35 degrees Celsius. We can prove why that's right by drawing a number line that looks like this. The temperature starts at 10 degrees. My blue arrow shows that it rose in the positive direction, 25 degrees, which means that it ends at 35 degrees. We can also bring in negative numbers. Maybe instead of the temperature rising 25 degrees, maybe the temperature actually fell 15 degrees, which is going to be a negative change because if the temperature falls, then it goes down in the negative direction, which means we have to rewrite our number sentence to say that it still started at 10 degrees. Then it changed by adding a negative 15 degrees Celsius change. And on the number line, we can show that, yep, temperature still starts at 10 degrees. My pink arrow shows that there was a negative 15 degree change, which caused it to end at negative 5. Y'all know this. You know how to drag chips around to show addition of negative numbers. You know how to draw a number line to show adding and subtracting negative and positive numbers. All right? Today, we want to move past those models, though. They're really important to help us check our work to make sure that we got it right. But we also want to come up with a way or a set of rules to know that we're always going to be right. And we call that rule an algorithm. An algorithm is a plan. We want to have a plan for when we are adding together negative numbers. Algorithms is your new vocab word. It just means it's a plan or a series of steps for doing a computation. Computation is like adding, subtracting, multiplying, dividing. Today we're focused on, I said it a couple times, adding, okay? What's really important is that we want an effective algorithm. So your job today is to explore and come up with a pattern and develop that algorithm that's effective because it will lead us to find the correct answer, no matter what numbers we're adding together. Let's say we're adding negative 4,562 plus positive 444. Doesn't matter what numbers. An algorithm is going to tell us what is always going to equal. You're going to be doing that by looking at 2 different groups of equations. I split equations into 2 groups for you. And you're going to have to explore, okay, what do all the equations in group 1 have in common? What do all the equations in group 2 have in common? And you're going to think, what do I notice? What's an algorithm or a rule so that I always know how to solve equations that belong in group 1? Or I always know how to solve equations that belong in group 2. You have 4 steps here. First, you are going to find the sums of each number sentence. Sum, remember, is the answer when we are adding numbers together. You're going to have to tell me, what do the examples of these equations have in common in each group? Oh, I noticed something that's unique about all the equations in group 1. I noticed something else that's unique about all the equations in group 2. You're going to write that there. Last step, you are going to be writing that algorithm. What's the set of rules for adding integers in both groups? Your document looks like this. So everywhere you see a red box, you are going to have to add your text. Check your work, please, by using the models that are on the very next slide to make sure you are getting it right.